Hi future GISPs. I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to spend years reading textbooks, getting degrees, paying for prep courses, and searching the internet for information like I did. In this video, I'm going to teach you everything I learned about map algebra. Map algebra is the fourth section under the Analytical Methods category of the GISCI Geospatial Core Technical Exam list of knowledge categories. Let's get started with section 604, Map Algebra. Map algebra is a set of primitive operations which allows one or more raster layers to produce a new raster layer. Map algebra is performed on raster datasets. Map algebra can be performed on a single dataset or on multiple overlaid datasets. Raster overlay. Raster overlay combines two or more layers. Raster overlay requires that the input raster systems be compatible. Raster overlay may require resampling before overlay. Continuous data is often converted to discrete data for overlay. Map algebra usually involves raster overlay. Let's take a look at some applications of map algebra. Map algebra is used in terrain analysis, change detection, spatial modeling, and image classification. Map algebra is used in terrain analysis to derive slope, aspect, hillshade, and viewshed. Map algebra is used in change detection to identify differences between raster datasets. Map algebra is used in spatial modeling to combine multiple layers to create new information. Map algebra is used in image classification to assign land cover classes based on spectral characteristics. Map algebra operations. There are several types of map algebra operations. Zonal statistics. Zonal statistics summarizes values in a raster layer by zones or categories in another layer. Combine. A combine operation assigns a value to each cell in the output layer based on unique combinations of values from several input layers. Single output map algebra. Single output map algebra combines multiple raster layers using an expression and outputs one raster layer. Most map algebra operations are single output. Weighted overlay. Weighted overlay assigns weights to each layer used in map algebra. Weighted sum. Weighted sum is a type of weighted overlay. Weighted sum overlays several raster layers, multiplying each by their given weight and sums them together. Unary operations. Unary operations apply to one data layer. Binary operations. Binary operations apply to two data layers. Boolean or logical operations. Boolean operations involve the comparison of an input cell to a value or set of values. And/or operations require two input layers. Output values are typically 1 or 0 for true or false. Not switches true for false and false for true. A null input outputs a null output. Conditional operations. A conditional operation is a condition that results in a true or false outcome. Local operators. Local operators operate on one cell at a time. Focal or neighborhood operators. Focal operations operate on a fixed number of cells around each cell. Focal operators may need to be adjusted near edges of raster layers. Focal operators are used in convolution, kernel filters, and moving windows. Focal operators are also called neighborhood operators. Zonal operators. Zonal operators operate on regions of identical value. Zonal operators are commonly used with discrete raster datasets. Global operators. Global operators operate on the entire dataset. Global operators are used in rescaling, thresholding, and normalization. Global operators produce statistics that summarize the whole dataset. A nested function. A nested function is a function within a function. Map algebra functions can be programmatically complex and have functions within functions. A clipping mask. A clipping mask is a binary layer that determines which areas will be included in analysis. Usually cells with a value of 1 are to be included, and cells with a value of 0 are not included. Classification. Classification categorizes geographic objects based on a set of conditions. Map algebra can be used to classify raster datasets. Classification is also called reclassification or recoding. Reclassification. Reclassification assigns output values based on input values. This is often done by comparing the input values to a table. Classification methods such as equal interval, natural breaks, and defined interval can be used in reclassification. Reclassification is also known as in-out. The terms classification, reclassification, and in-out are all essentially the same thing. The different terms for classification are used in different situations, but they are all the same thing. Now you know everything that I learned about map algebra to easily pass the GISP exam. Don't forget to thumbs up and subscribe to my channel so that I can keep helping people pass the GISP exam and achieve the rewarding careers in GIS that they deserve. You can also find everything I learned to pass the GISP exam in my book, The Ultimate GISP Exam Study Guide, available on Amazon. My study guide is an easily understandable, comprehensive, graphical, all-in-one resource for passing the exam. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam.